Hey, grade 9s. In this topic 8, we're going to be talking about electrical power generation and how it potentially affects the environment. This is going to help you go through your notes package, find those answers for topic 8. And so we're starting here with a thermoelectric generating station or plant. This plant is going to rely on fossil fuels, and that's primarily how we make our electricity here in Alberta. I'm not going to go through all of it in great detail, except to notice that over here we have some kind of fossil fuel, and in this diagram it's going to be coal. The coal goes into a boiler, and we've got some water moving through some pipes, and that water gets superheated. We create steam. The steam goes through a turbine, which then causes that rotational motion to cause the coils of wire in this generator moving in a magnetic field to create our electricity. And so that's kind of how it's done here in Alberta primarily. Now, guys, this leads us into a conversation between renewable versus non-renewable resources. Non-renewable sources, such as fossil fuels, coal, oil, and gas, means that we're going to be running out of them. There's not a continuous supply. Some negatives also is that we're going to get air and water pollution. You might have to have an open pit to mine your coal or to get your oil. That may disturb the soil and the environment. It also can contribute to the greenhouse effect because we're producing a lot of carbon dioxide, a greenhouse gas, and so there you go. On the flip side, this chapter discusses some renewable sources of generating electricity in a plant of some sort. So we can harness wind power. We see those great big wind farms, especially in areas of southern Alberta, or water power, which is used quite a lot in Ontario and Quebec because they have a lot of lakes and just a lot more rivers to provide water power. We'll see how that works in a second. Or solar power, solar panels, solar farms, ocean tidal power, which we'll see how that works in a little while, or we could harness the energy that's within the earth itself, the geothermal energy. Also, we could, another renewable source that we could burn besides fossil fuels is any biomass, so wood, that kind of thing. All right. Now let's take a look at how a hydro power plant works. So you need to make a dam, and you dam up a river, for example. That puts a lot of water behind the dam, which creates an awful lot of water pressure. And then down here, you allow the water to flow from its area of high pressure to an area of lower pressure, and gravity is providing that force. And the water is going to go through essentially a water wheel, which is this turbine, which again we know runs a generator to create the electricity. Then the water is allowed, of course, to continue its flow downstream. Or we could have a nuclear plant, and in this case, we're going to use a material that's radioactive. In this plant example, this is called a fission reactor because we're taking some nuclear material and it has the tendency to break down. So fission is when larger nuclei release particles and break into smaller nuclei, and in that process they generate a lot of heat. So that's here we have control rods of nuclear material that are able to be lowered or raised to control the amount of heat generated, which again causes water to turn into steam. And just like the fossil fuel thermoelectric station, we're just going to use that steam to turn a turbine, which again is connected to a generator, which makes our electricity. Now the next slide gives us the difference between fission and fusion. So fission is where larger nuclei are breaking down into smaller nuclei. Fusion is the opposite. It's where smaller nuclei are fused or made to come together to make a larger nuclei, and this still generates an awful lot of heat. It's the way the sun works. The sun is taking hydrogen atoms and under intense pressures is able to push them together to make a helium atom from two hydrogen atoms, and that creates a lot of heat, and that's essentially what the sun is providing us with on a daily basis. Now we could harness the energy of the tides, and that can be done in a number of different ways, but essentially, again, you're going to have a turbine that is capturing the energy as water or the tides are driven by the actions of the sun and the moon. And just again, it's a natural process where water is just moving through one way, if the tide's going to be moving this way, and we've got turbines that are situated to capture that energy, or again, if the tide's moving the other way, essentially it works like a wind station, but under the water. Lastly, guys, there's this thing called cogeneration. So if you're going to have an electricity generating system that's functioning using a lot of heat or steam, it kind of makes sense to perhaps use that heat or steam to either generate more electricity than you actually need. You can sell it back to the grid, or let's take that heat, that hot water, that steam, and let's use it to heat large buildings. In that way, it's just being much more efficient. It's called cogeneration because co means you're generating not just one thing, but you're able to use generating two or use two more things like electricity and also heat, two different forms of energy. That's topic 8, guys. So happy studying.